All right, guys, let's talk a little bit about pre-calculus this week. We got our first assignments going too, so let's talk about how we get to our assignments and our lessons and all of that good stuff. So I'm going to put up here on the screen. Let me move that over where I can pull it up here. All right, I'm going to pull up on our screen our Google Classroom, and I'll show you. I have added this morning. Make sure you had on there a link to Buzz. I put it right here on the front page. It's right down here in blue. So this is our just kind of official post. See Home Access Center for official grades. For class, we use this link up here, which you guys know. For classwork, use Buzz, and for like tutoring time during Flex, use this class video meeting at the bottom. So this is kind of a little bit of an everything post right here in the front. So there is the link to Buzz. I also want to show you while I got you here. I've uploaded our textbook. The in Buzz, it actually gave a link to a sign in where you had to go sign in for the textbook and wants you to go to pages 88 to 92 or something. So instead of doing that, I have taken those pages and put them in Buzz. So you have them right there in Buzz. But at any time, if you want to, you can come here and look at the entire textbook. All right, it says the entire textbook, including it'll have practice problems. You can do additional practice problems, and it has like the answers to the odd ones, just like the old math books we've had in all of our classes. When they hand you a book, got the odd answers in the back. So there is the entire textbook that we will be using here in class for us this year. But let's go back here, and I want to show you. So when you go to Buzz, make sure you can log on. It'll take you to the Buzz screen. And I'm going to show you, in case you don't have your log on, if you haven't tried it yet, what your log on should be. So you need to try that. Make sure that Buzz is working for you this morning. If it's not, let me know, and I'll have to get with our Buzz tech and get that reset for you. But when you log into Buzz, your last name, first initials, or whatever your email is, whatever your Bentonville school email is, whatever that name is, that goes as your username. Online 2021 with the capital O is what you will use as the password. Now, if you were on Buzz last year, it's possible whatever your last year password may still be the active password. But if it's been reset this year, if you had to be added this year, this would be the password that's currently being used. So make sure you can log on to Buzz and get into there to see our class. So once you get into Buzz, again with the username, everything before the at, and the password online 20, then that's a capital O and no spaces, online 2021. Let me show you what you should be seeing. So let me switch to a different screen here, and I will show you what you'll be seeing when you get to Buzz if you haven't already been there. Okay, right here. All right, from the student screen, I'll have all your classes here, any other classes you have on Buzz, and you're going to look for the Brock 0B, the pre-calculus. You see this big pre-calculus thing. So when you go to that and click on there, here is what you have visible currently right here. Um, we have the welcome, which just basically has some course information and talks about what the lessons look like. You can read that if you want to. It's not necessary. It just basically talks about Buzz and how it operates for this. Uh, this little motif, course specifics, again, just detailed information about that. But here's the module. This is where we're starting functions and their graphs. So we kind of start with a review of functions and getting into some detail on that. This did have an interesting thing. I left this in here, this module one study plan. If you're someone who likes to do these type of things, I'll show you what this looks like. This has kind of a scenic overlook, they call it. They like to give you like the big look. Here's what we're going to be looking at. So for the first module, uh, module study plan, functions and properties, that's lesson one. Graphs of functions, lesson two. This is all the stuff for this module. It has how long they expect it should take to do these lessons. All right, so there is what their expectation is. So this has you can copy and paste this chart into a blank word processing document. You can put in when do you think you'll have those completed. Like I said, we'll just assign probably a couple of week. It may vary depending on the size of the assignments. And this is where you can make a study plan. You can explain how you anticipate plan compares to the pace chart for the entire course. Do you think it'll, when you start working this out, you figure out, is it taking me 90 minutes to do that? You can save your study plan on your computer. You can print and post it in your workspace. You can keep your progress. And this is submit your study plan. I took out the submit it. I don't need your study plan. If you want to do one, you don't have to submit it to me. So I took away the part where it lets you submit it. So it doesn't even let you submit it. But that's just something it has in there at the beginning. I thought was kind of interesting. So let's look at what one of the lessons look like here. And since we'll be meeting again on Thursday this week, this is our second week of school, so we meet every class period. We'll be meeting again. We'll look at lesson 2 at that time, the graphs of function lesson. We'll look at that on Thursday. But I'll look at this first this morning, functions and properties. Now, again, I just uploaded the textbook here because we don't have a link to go log in and access things from other pages. So it's on here. And if it's a little small for you, you might want to raise, the size of the view so you can make that bigger on your screen. I'm going to make that bigger on here. But again, this starts with a scenic overlook and talks about the basic lesson, what it's about. So it's talking about functions. If we drive at the interstate at 70 miles an hour while traveling to Yosemite National Park, how far would we travel in a given number of hours? All right, that's number one. Or if I were to purchase a certificate of deposit paying 4.5% interest per year, how much would it be worth after a given number of years? So different things that actually are functions about everyday life. We can create a chart to show these possibilities. So on the first example, 1 hour, 70 miles, 2 hours, 140, all the way on, 5 hours, 350, 8 hours, 560. This is just for every hour you go 70 miles because you're driving 70 miles per hour. You could also list some order pairs, 1, 70, 2, 140, 3, 210, right? We could do functions as ordered pairs. We can do them as a graph. We could do them as a chart, a table. There's just different ways you can do all of that. So definition of a function. A function, F, is a set A to a set B of rule, is a rule of correspondence that assigns each element X to us in the set A. Okay, this is very wordy this early in the morning. A function is a set A to a set B, from a set A to a set B, is a rule of correspondence that assigns to each element X in set A exactly one element Y in set B. Basically, that's saying there's one Y for every X, right? That's how we've always said that. One Y for every X. This is the real wordy mathematical definition of that. So one Y for every X. Set A is the domain of function F, set B is the range, right? Because the X is the domain, Y is the range. So here is, and anytime it had these things, I made this where it actually would work for you. Test your skills. It says, look at these and figure out which of these are functions. So you can go through these examples and say, is A a function? 4, 2, 3, 1, 2, -1, 1, -2. Is that a function? Is this a function? Is this a function? And when it says check your answers, I've added where you can click on that and it will open up another Google document to where you can actually check your answers. So when I click on that, it will open up this Google document, which is called Check Your Answers. 1-on-1, check your answers. And there are the answers for A through F. So you can go through and make sure you're understanding, make sure you're answering correctly, and actually look at those answers right there. There's another one down here, another check your answers. It opens up a different document. There's another one here, different document. So anytime there's a check your answers. But anyway, that's the scenic overview. We get down to this page. Here's the actual textbook. And you can also access that on the textbook link on Google Classroom where I uploaded that. 1.2, functions and their properties. That's the name of this lesson right here. So talks about the definition of a function, domain, and range. A function is this set D to a set R. Is a rule that assigns every element in D a unique element in R. Set D is the input values to the domain. That's the X's. R is the range. That's the Y's. All right. So This is kind of set up a little bit more of a college type textbook. A lot of high level math language, which is good for you to see and all of that. It gets you ready for like the ACT and those type of things and going to college, seeing these. So this is um, mapping out a function here. Like when I hear this first looks like a couple of kidney beans or something, right? If you see in example A, every X in the domain has one arrow going to a Y. Every X has one. Now, some of them go to the same Y. See, X3 and X4 both go to Y3, but they only have one. Example B, this is not a function because if we look here, X1 has two different arrows. X1 goes down to Y3 and it goes over to Y1. So that's how it makes it not a function. This should be a good review for you. You guys have probably been studying that since middle school or earlier. Functions are one y to one x. So this is starting out just kind of a review of that. Defining a function. Example one. Does the formula y equals x squared define y as a function of x? If it defines y as a function of f, that means it's a function. It defines y as a function of x. Yes, y is a function of x in this case, because we can write the formula f of x equals x squared. And when you put an x in there, it comes up with exactly one value for that x. So there's no ambiguity about what the square of x is. So if you put it in there and you could get two different answers, then it would not be a function, right? Graphically, it talks about how you look at a graph of an equation to figure out if it's a function. And of course, there's the vertical line test. Example A and example B, if you drew a vertical line straight up and down, it would only touch the graph at one location, no matter where you put that line. The example C, if you draw a up and down line, it's going to cross in multiple places, which means that is not a function. So the vertical line test, and it gives a little box to define that. It's a graph in the xy plane, defines y as a function of f, and if no vertical line intersects the graph in more than one point, it would pass the vertical line test. Domain and range, finding the domain of a function. So that's all the possible x's. So if we define the domain, like look at A, f of x equals the square root of x plus 3. What would be the domain of that function? What is all the possible x's for f of x equals x plus the square root of x plus 3? Put that in the chat. What is the domain of f of x equals the square root of x plus 3? What is all the possible x's for that function? I need some Jeopardy music to play while I'm waiting on you guys to come up with an answer. Do, 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 do. What is the domain for example 3a there? F of x equals the square root of x plus 3. What are the possible x's? Is it all real numbers? Is it negative infinity to infinity? Is it something else? What possible x's can we put in there? If it was just f of x equals x, right? Y equals x, we know that's negative infinity to infinity. It's all possible numbers. It's all real numbers if it was just x. But is it the same? Square root of x plus 3. Let's see, could we put 0 in there as x? Let's see. 0 plus 3 is 3, square root of 3. Yeah, square root of f of x could be the square root of 3. So 0 is in the domain. But what else is in the domain? What is the entire domain? What is the span? If you guys can't even answer one, we're going to have a lot more class participation to wake you guys up here. -2 to infinity, question mark. Okay. X is greater than or equal to -3. And I don't mind you taking a guess if you don't know, because that's why we're going over this. So let's see. Daniel said -2 to infinity. So -2 plus 3, give it 1. So he's saying anything square root of 1 or larger. So square root of 1 would be 1. That's a valid number. Savia says -3 or greater. So -3 plus 3. Square root of 0. Is that valid? Do we know what the square root of 0 is? Yeah, that's 0, right? That is a number. But anything smaller than -3, if this is -3.1 plus 3, then we'll have negative square root. Well, the square root of a negative number, even if it's a negative 0.1. We cannot take the square root of a negative number, right? At least not in real numbers here. We're not dealing with imaginary numbers at this point. So yes, Savia's got it. The x is greater than or equal to -3 would be the domain of that right there, because x cannot be anything smaller than -3, or else you've got a negative number underneath there. Looking at the second one, B, that gets a little trickier on our domain. We have a fraction, and on top of the fraction, we have the square root of x. So we know that the domain of that has to be 0 or larger, right? We can't have any negative numbers. No negative numbers, because we can't take the square root of a negative number. But we also have on the bottom of the fraction x minus 5, which means x can be 0 to infinity, except for 5 cannot be in the domain, because 5 minus 5 would make 0 in the denominator, and we cannot divide by 0. So that domain gets a little trickier. It's the set of all x's such that x is greater than or equal to 0, with the exception of 5. Cannot be 5. X cannot equal 5. So when you go through this, you need to go through these lessons, look at the examples. You can do them on paper, you can do them in your head, see if you're understanding. See, now down here a little farther, here's solutions. They're letting us know what the answer is. X is greater than or equal to 3. B, we were just talking about, x is greater than or equal to 0 because of the radical, can't be negative, but also the denominator of a fraction cannot be 0, so x cannot equal 5. So the domain of G is the interval 0 to infinity with the number 5 removed. So we can write that as a union. I don't know if you remember unions before from your earlier algebra classes. Union is to where it's 0 to 5, and the bracket means includes 0, and 5 to infinity, but the 5 has parentheses because 5 is not included. So it can be 4.999, or it can be 5.0000001, but it cannot be 5. So everything from 0 to 5 and 5 to infinity, not including 5. So graphically, and I will put a link to Desmos on there, where you can go to Desmos and graph and just click on that. I'll put that in Google Classroom as well if you want to use that graphing software where you can make these graphs and check things. Finding the range. Now the range is all the possible y's, all right? All the possible y's. So this asks the graph of y equals 2 divided by x. Is y equals 0 in the range? Can y ever be 0 on this graph right here? It will not. We have an asymptote where y equals 0. And coincidentally, where x equals 0, there's an asymptote also. So there's no way that this graph will ever touch the 0 on either axis anywhere. It'll get closer and closer and closer, but never touch. So y equals 0 is not in the range. Everything bigger, everything smaller, but not y equals 0. So that's right there at the end of that lesson. I'm going to go ahead and make that a little smaller. After you go through the lesson, like I say, you can make it bigger or smaller to see as much of the page as you want at a time. After you go through our lesson, go back with this arrow and you'll have our first assignment. Functions and their properties. There was the lesson, there's the assignment. And when you go to the assignment, well, as it says start, I already looked at it once, but there are some multiple choice questions. And at the bottom, there is a question right here that you answer. Or, at least one question. You may have more, but where you have to type in your answer. But you have mostly multiple choice and then some that you have to type in. I'm going to leave because I didn't finish it there. And so looking at Buzz, there's one thing I want you to get used to looking at. I know that a lot of people like this to-do list. The to-do list is somewhat useful, but a lot of times it doesn't help you, especially if you get behind on things, because it could take things off your to-do list that you've never done. Where once you get used to going is this grade screen. This little icon here take you there, or you can click on grades over here on the menu. And this is a great place to go and keep track of your assignments. This will show what assignments are out there, and their due dates will be over here on the right side. So you can keep track. When I have more assignments out there, it'll have more of them have different due dates. It'll show you what your grade is if you've turned it in. It'll have a check mark showing you've turned it in, and it will have the date that you actually did it. So get used to going to the grade screen to see what's due, what your grades are, what you need to turn in, what you haven't turned in, what you already turned in, all that kind of stuff. And remember, this year with the new grading system, evidence of learning is the only thing that counts towards your semester grade. The homework and practice does not count towards your semester grade, but it is critical that you understand the problems and do well in the homework and practice so that when we get to quizzes and tests that count as evidence of learning, that you can do well on those. So if you're not doing well, if you do these assignments and you score very low, you probably ought to go back and look at them again and maybe go back to the lesson and see if there's something. Did you make just a small mistake and now you understand it, or was you totally lost and you need to go back and review that, or you need to get with me and say, okay, Mr. Brock, I've gone back on this. I still don't understand it. I'm kind of lost. And then we can go through these things together, because I don't want you to still be lost when we get down to the test or we get to a quiz or anything on that. I don't want you to still be lost. I want you to be on top of the game and ready at that point. So, all right. Any questions on how Buzzes works, or you understand where the textbook is now? What the lessons are in there. Understand what the assignments look like. All of that good stuff. I just want you to be ready to rock and roll this week, because this is your first assignment. It's out there. They're due Sunday.